Hi, linear algebra students. So this is video number 2 of the makeup class on projections. Okay, so in this video, we're gonna set up the distance from a point to a line, and we're gonna do one example. Okay, and oh, by the way, distance from a point to a line, but also how to find the closest point on the line to the point P. Okay, forget about the setup that's over here for now. I will set it up entirely here, and then this is the method. Okay, we will discuss about the method, but focus on the drawing for now. Okay, so the first thing we're gonna do is we're gonna take the position vector of the line that we are given. And by the way, we're given two vectors. We're given like the position vector of the line, but we also have the direction vector of the line. Okay, so this is all what's given to us. Okay, the first thing we're gonna do is we're gonna draw a vector from the position to the point P that is not on the line. Okay, and for the sake of giving this vector a name, we will call it Q. Okay, this is step number 1. You have to reach the point from the line with some vector. So as you can see, Q will be the point minus the position vector of the line. Okay, the second step is to use the projection concept that we have seen in the last video to, that's it. What we want to do is to project this here. Okay, so this will be the projection of Q on the vector V. Okay, so this is step number 2. You want to figure that out. Okay, so you're projecting the vector Q on the line in some sense. Okay, and this will give you the closest point to P. So the closest point to P is the point that's right here, the X naught. Okay, so in my guideline, it's in blue. So let's actually, so the X naught here, this is the closest point. Closest to P. Okay? So how to find it? Well, you want to add the projection to the vector P, right? So it's going to be P plus the projection. You will reach that point. Okay? Then after that, to continue and to go on and find the distance, then you want to calculate the perp, right? So this vector right here, this will be the length of the vector will give you the distance between the point and the line. So this will be the perp of Q on V. And last step, as you can see, it is to take its norm. So the distance will be, that's it, the length of that perpendicular vector. Okay, so far so good. Before going to the example, I want to say that this method is working also for two parallel lines. So here I drew the setup already, just to not have to do it twice. This is my line number 2, and this is my line number 1. Okay, so the only difference is that Q will go from your first line to your second line. Okay, then the rest is the same. You project to get the closest point to x2. You would add the position vector p that I didn't draw here, but I could draw it again. It's like the vector p that's right here. You would add it to the projection. Okay. But this will give you the pair, like x1, x2. So this is a pair of closest points. So you by adding like a scalar multiple of t, you will get like another pair of closest points. Okay, so keep that in mind. And also, the distance works out the same way. So once you found the projection, you find the perp, and then you take the norm. Okay, so just so you know, this setup and this setup are actually the same. Now let's go to the example. So now I'll just keep the drawing, okay? I'm erasing the method. So we are given, so consider P, which is 3, 1, 2. And the line is going to be X equals to 1, 1, 3 plus T times the vector 3, 0, 1, where T is a real number, okay? And what we want to do is number 1, find the distance from P to L. So that's question number 1. And question number 2 is to find the point on L. Point on L that is the closest to the point P. All right, so let's put the color where we can before we start the problem. By the way, we will do them both at once, okay? So here, this is the position vector. This is it. Now, this is the direction vector. And the point P is over here. So step number 1 again is to compute the vector Q. So Q will be so this point that I'm going to color code in green in the steps. So it's going to be like 3. Actually, let's write it in vector notation, which means like in a column. So 3, 1, 2. I'm taking this thing right here. Minus the vector P, right? Which is this one. So 1, 1, 3. And then you just calculate the result. You're getting 2, 0, negative 1. So step number 2 is to compute the projection. So projection. First of all, let's write again the formula, okay, before we move on. So projection of Q on V. So I want you to remember that this is the vector Q dot vector V. Okay, and since we're projecting on V, it means that we're taking the norm of V squared and we're multiplying by the vector V itself. Okay, so let's calculate this. We're having, so let's say here, plus, plus. And same thing here, plus, plus, and like we'll square some of the things. Let's just write the canvas. Okay, so here, vector V is the vector 3. So 3, 0, 1. Okay, so these are the components that go here. And these are the components that go here as well. We have like 3, then we have a 0, and a 1. And we put the components of the vector Q that we found in the preceding step. So 2, 0, and negative 1. Okay, so from there we just compute, right? So we're getting 6 minus 1, 5. This is going to give us 10. Multiplied by the vector 3, 0, 1. So 5 over 10 is 1/2. So overall, what we're getting is 3/2, 0, 1/2. Okay, so step number 2 is done. Now we're going to answer this question. Find the point that is the closest. So we want to find the x naught. Okay, so this is step number 3. So x naught is going to be the vector P that we have right here. So let's put it down. 1, 1, 3. Plus the projection that we computed in the preceding step. So it's going to be now here 3/2, 0, and 1/2. So as a result, the closest point is going to give us 5/2, 1, and now this is 6/2. So we're going to have here 7/2. So this is the answer to question 2, right? And then we're proceeding. So now I think I can erase. Yes, I think that's what I will do. I will erase the drawing because I want to try to finish the problem here. It's going to be hard, but I mean, there's no hurt in trying. So now we want to find the perp. Okay, so perp of Q on V. Okay, so we take the vector Q. The vector Q is this one. So 2, 0, -1. And we subtract from it the projection, this guy right here. So subtracting the projection, we get like 3/2, 0, 1/2. Okay, and what do we get out of this? We get, so 2 minus 3/2 is 1/2, then 0. And here we're getting -3/2. Yeah, perfect. Which means that finally, number 5, the distance, which is simply the norm of that vector. So it's going to be the square root of 1/2 squared plus, let's say, 0 squared. I'm being lousy here. Plus -3/2 squared. So now the rest is just the calculation. We're getting here 1/4 plus 9/4. Which means here that we're having the square root of 10/4. And the only thing I'm expecting you is to simplify that a little bit. So we're going to have here the square root of 10 divided by 2. This is our distance. So this is the answer to number 1. All right. Hopefully this is good. Hopefully this helps. So in the next video, we're going to do the same setup for a plane and a point, right? So we want to find the distance between a point and a hyperplane. All right. See you there.